Exercise 8 is going to assist us to answer the question that says, why are we learning these trigonometric ratios? And how are you going to apply them in real life instances? Well, in the first exercise, the first problem in exercise 8, we're given table mounting, and this is a cable card that's going to be dragged all the way up by a machine to the tabletop, the table mounted top. So remember, the cable car is actually something of this nature, and it's got a hook on top. Now that hook there is suspended on a cable, a steel cable. Now, depending on the angle that is made here by the cable versus the surface of the ground, and the cable, one understands that the cut should not touch the cable for it to operate smoothly, because if the angle were to be increased, say maybe to this side, you might find that this cut starts to cut into the cable such that now it will damage the cut. That cable, it will either damage the cut or the cut will damage the cable. So there's a certain angle that needs to be used, or maybe put in place for the cable to be able to safeguard the cut, and the cut to safeguard the cable in return. So in this case, we are told that the cable and the surface of the ground form 40 degrees. So I guess this is the safety angle. That's the safety angle, or the appropriate angle in order to be able to pull the car up to the mountain. And we're told that the length of the cable is 1.2 kilometers to the top of the table. Now, looking at this, one can identify that if I were to draw a line perpendicular to the surface of the ground, this becomes a right angle triangle. We're actually expected to find the height of the mountain. Now, the height of the mountain will be obtained by using trigonometric ratios. I'm going to write here, so as always, our acronym is going to come into play. Therefore, we start by identifying the sides. Now, this side is hypotenuse, and this side would be adjacent, and this height side would be opposite, the opposite side. So, for us to obtain h, it means we're going to have to say opposite side and a relationship of one given side. That's going to be my hypotenuse and the angle 40 degrees. Then that is going to be a sine function relationship. So that's going to be sine 40 degrees would be equals to the opposite side being h all over the hypotenuse side being 1.2 kilometers. Now, making h subject of the formula, h is going to be equals to 1.2 kilometers sine 40 degrees. Therefore, h will be equals to, we punch that into the calculator, is 1.2 kilometers sine 40 degrees. That gives us about, that's going to be 0.8 kilometers. 0.8 kilometers. So in essence, if we were to convert this to meters, therefore h would be equals to 800 meters. 800 meters. Okay.